In mailbag 42-ish, I picked up 10 of these. Prices in the corner there. They're step-up converters. Yeah, put in 2 to 24 volts DC this side, and up to 28 volts DC comes out this side. There was a comment that these things may not last that well. So I'm going to go do some testing, but first, what I'm going to do is compare this design versus what the manufacturer recommends. And here it is. They're almost identical. First off, this is not an MT3608. It is a B628. And I found the spec sheets on both of these, and if you overlay them, they're basically identical other than the company name and the part number. The manufacturer recommends 22 microhenries, and they're using 22 microhenries. Right there. Okay, flip it over. The wiring is exactly the same. They recommend a Schottky diode. There you go. It's an SS34. That's good. The resistance divider bridge is good. Input capacitors, well, since I already toasted this one, I pulled off the first capacitor and pulled off the other capacitors so I could test them. Here's my little test setup. Not one of those fancy ones, but it works. Now these are, the recommended is 22 micro, oops. Okay, the recommended is 22 microfarads, and these are probably 4.7, that one at least. My other one is, if I got connection there, again 4.7 microfarad. So they did change the input and output capacitors from the 22 microfarad, but the rest of the circuit is identical, and they recommend a large ground plane, which is pretty well the hole back there. So now it's time to do some testing. Oh, this caught me by surprise. The resistor here, it's hard to see, but it says 338. I'm like, wait a second. That's 3,300 mega ohms. That can't be right. Well, that's if it was an EIA numbering system. This is a EIA-96, which means you better look up it on the chart. 33 stands for 215. That's not an 8, it's a B times 10. So in the voltage divider, they've got 2,150 down here. And up here it'd be, let's see, 100K. I've noticed looking at some of the pictures on AliExpress, some of them put in a 10K resistor or potentiometer up here. But other than the input capacitors, this is built to manufacturer specs. So here's the plan for some testing. Here's a chart. I'll put it up in the corner there. I've got 5 volts set up there. And what I've got set on here is 12 volts. So I'm basically going on this chart here for their efficiency. And you're going to have to keep it in the efficiency, like good efficiency area, whatever good is. Otherwise, the thing will generate way too much heat. So, right now I've got 30 ohms, three 10 ohm resistors. Uh, this is set at 12 volts. So that means I should be getting about 0.4 amp out of here, which I'm getting. Right now, set up like that. Let's see what its temperature. Not bad. I'm just going to do nothing feels hot yet. So that's at a fairly efficient level there. What I'm going to do next is decrease the resistance to 20 ohms, which would give a 0.6 amp draw. So now it's set up just 20 ohms resistance. The voltage actually went up a tiny bit. Oops. Let me readjust my meter. Okay, so now I've got 12 volts still, roughly. It changed a tiny bit. And I'm drawing almost 0.6 of a amp. Still fairly cool. Let's just take a look at the resistors. Not the best setup for it. They're starting to get a bit warm. That's warmed up a bit, not much. The Shocky's still saying cool. Not too bad. Let me do the... Doesn't feel hot. So, going from 5 volts up to 12 volts with a half amp draw on the 12, this is working fine. This is not a long-term test, obviously. Now, I'm going to step it up a tiny bit more. What I'm going to do is adjust the voltage in to 13 volts and this output to 18 volts. So I've got the input at 13. I've got no load hooked up. The output's sitting at 13. I need to adjust it up. Oops. Hard to turn this thing. My focal distance isn't that great. Okay, I'm going in the right direction. I'm going to take this up to 18 volts. Closer, closer. Okay, there we go. 18.3, no load right now. So now I'm going to put in a 50 ohm load. It should draw about 0.36 amps. So, and it is 0.35. So we're still, okay, at that point, we're on about here. We're in the high efficiency. We're not doing a super large draw on it. It's just doesn't feel warm at the slightest. And it's not. Resistors are starting to warm up a bit, or they're still warm from the last test. So right now, if I'm at a 360 milliamp draw, Looks like it's working fine. So the next test is to make a big draw on it. I'm going to have the 13 volts coming in, 18 volts coming out, 12 ohms worth of resistance, and that should give me a 1.5 amp output. Just double checking. This is still all cold. So this type of draw, fine. So what I've done is I've replaced that 50 ohms with 2 6 ohms in series, so 12 ohms, with the 18 volts hopefully coming out of this thing. It should be 1.5 amps. And I've made sure that's on the right scale. It's either going to smoke or it's going to work. It's going to smoke. Ooh, not bad. Oh, it's still smoking away. And it's outputting 1 amp on 12 volts. So, at this point in the chart, I've disconnected the power. Right here, see, let's double check. That's 1.5. Good, camera was on for it. It should have actually worked, and it didn't. So, question is where will it actually start working? So let's snip this one out of the circuit and take a quick look at it. Then I'll do another one. Ew, there's a... Wait, come on. You were in focus there. There's a bit of a skid mark in there. Oh well. And keep in mind that was within their chart of efficiency. So let me just solder in another one. Waste another 38 cents. Okay, load is unhooked. And I'm just going to adjust the voltage up to 18. And the only reason I'm recording this in case it decides to go poof. As I said, no load right now. So I've now got I've got 4 6 ohm resistors. That's 24 ohms in series. That should give a current draw of 0.75 amps if it's going to work. So let's see if we get the puff. And I just double check to make sure camera is turned on. That ain't good. Okay, everything's connected. And right off the bat, it pulls the voltage down, and it's on half an amp. So this won't even draw 0.75 amp, even though it says it should. I'm just going to disconnect the load, and it's fried. It's staying at the 12.84. I better get a look at the temperature quickly. It feels actually a bit warm, but obviously it fried. So what they claim on the package is not real. Even at 0.75 amps and a voltage of 18 doesn't work. It's toast. So the comment about ampage is good. So here's summary. On the 5 volt, it worked. On the 400 milliamp and the 600 milliamp. On 13 volts with 18 out, worked on about the 360, I think it was, milliamp, but failed on the 750 milliamp and spectacularly failed at the 1.5 amp. Now, I kind of wonder if you need almost a slow startup on it. And maybe it's an initial spike going through that's toasting it. But that's not going to help, because unless you've got that built into your circuit, this thing's going to go poof. So I think it's usable for some uses. My use for it on here was down in this area, so I'm going to be able to use it. And the other was the 5 volt, and that's going to work. So I've set it up again with the 50 ohm, it's just 50 ohms, 13 volts in. It fired up fine. It's drawing 0.35 of an amp. So the next step is going to be, I'm going to do a soft increase in current. Okay, see if you can see this. So what I've got is the 6 ohm one, and I'm going to put it in parallel with 20 of the ohms. That would reduce it down to the equivalent of something. Okay. This would be equivalent to a total resistance of 34.6. And the current went up a tiny bit. Now let's take it to where we would have 30 ohms in series, and then 6 ohms in parallel with 20 ohms. We're up to half an amp through, and it hasn't failed. Now let's do it for 20 ohms in series and 30 ohms in parallel with 6 ohms. We're up to 0.7 amps. It's just, this is not hot. Oh, that's interesting. Okay, so let's take now 10 ohms plus 40 ohms in parallel with 6 ohms. And toast. Ooh, very spectacular. Oh, that's definitely going good. I think I'll turn off the power and put out the fire. So that was the limit, and I'll calculate what the resistance was. Don't know why, but that felt really satisfying. There's not much left in there. Diode still looks good. The rest arced and burned. So in summary, stepping up the resistance slowly, hence increasing the current, or decreasing the resistance slowly, increasing the current. It seemed to work at 0.72 amp. Then when I went that little bit further, where Okay, there the resistance was 25 ohms. When I dropped it to 15.22 ohms, which should have actually given a current of, I believe it's 1.1 amp, which is within the specs, it went poof and burned. So use these things with caution. Have a good day. That was fun. Actually, it was way too much fun. Bye.